So today we're going to start section 1 from chapter 5. We won't finish it, so we're going to actually spend 3 days going over this PowerPoint. Today we're just going to focus on the graphs of the exponential functions. So an exponential function is going to be a function with a base a, and it's usually, and it'll be written like a raised to the x power, where the a that's in the equation here, this base, is going to be a number that's greater than 0. So a is just a number. The exponent, this is going to be a variable. So a can't equal 1, but it's going to be a number that's greater than 0. So it could be a fraction. And we're going to see the difference between the two graphs when a is a fraction and then when a is actually a number that's greater than 1. So here are the two general shapes that we're going to be seeing for our exponential graphs. So the one on the left, this is when our base is going to be a number that's greater than 1. The graph that's on the right, this is when our base is going to be a fraction. Now, we're also going to be shifting these graphs up and down and left and right, and we're also going to be reflecting them. So you may see some that are reflected across the x-axis, but these are going to be the general shape that the graphs take on. Most of your graphs are all going to include this ordered pair of 0, 1. Because remember, anything to the 0 power equals 1. Now, it says here to use a t-chart. So what I mean by a t-chart is we're just going to make the letter t. I'm going to pick values of x, and I'm going to substitute them in to get my y value, or what the function equals. So like 2, let's say it was 2 to the x power. I'm going to pick values of x, plug them in, and then solve 2 to the first power, or 2 to the 0 power, and so on. So some of the exponential functions that we'll be graphing could be, for example, 2 to the x. That's going to be the first example I do on the next slide. You might get something that equals 10 to the x, and then we'll also do some with some fractions raised to the x power. We're going to do examples of all of these. So let's go ahead and try our first example. And it's going to be f of x. And again, remember, f of x is just a fancy way of saying y equals. So for my first t-chart, I'm going to actually plug in a lot of values for x. Just to review what happens when I plug in, for example, a negative exponent, and when I plug in 0, and when I plug in a positive number. So let's make our little t-chart. And then I'm going to be plugging in and doing y equals. So the answer I get when I plug in the number is going to be my y value. So I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. So let's do the math. So all we're doing is plugging in. So I'm going to do 2 to the -3 power. If you remember back from the beginning of the year, when a number is raised to a negative exponent, it doesn't make the number negative, it makes it a fraction. You move the whole thing under a 1, so then it becomes 1 over 2 to the third, which equals 1/8. I can do the same thing for the -2. 2 to the -2 power becomes 1 over 2 squared, which is 1/4. Plug in the -1 as the exponent. 2 to the -1 is really 1/2. You also need to memorize that any number raised to the 0 power equals 1. Then if I plug in 1 as the exponent, 2 to the first power is 2. If I plug in a 2 2 squared is 4. And then if I plug in a 3, 2 to the third power is 8. Now, the x that I plugged in along with the answer I got becomes the y, and these become ordered pairs that I can graph. So let me go ahead and graph. I'm going to graph -3, and now these fractions right here, they're kind of a bit challenging to graph, but we're just going to put them, you know, a little bit in between. So -3 and then 1/8, -2 and then 1/4, then 1/2, and it's sweeping up to 0, 1. Then I'll graph this order pair 1, 2, then 2, 4, and then finally 3, 8. And then your graph is all going to take on this general shape. It's sweeping up here to the right, and then it's going to skim along the x-axis because we have a horizontal asymptote at y = 0. Our graph is never going to cross this horizontal asymptote. So all of our basic exponential functions all have a horizontal asymptote at that x-axis at y = 0. Now, if our graph gets shifted up or down, then our asymptote will also shift along with the graph. And we're going to see that in the last couple of examples that we're going to do here. Now, when you're graphing these, I don't expect you to give me this many order pairs. I only want to see you plug in at least 2 numbers because they're all going to take on this general shape. Let's try the next one. We're going to cut down on the numbers of that we're going to plug in and fill in our t-chart. Now, notice over here on my x column, all of these numbers are slowly approaching infinity. So these are gradually going to infinity. But this side, on the y side, these are also going to infinity, but faster. They're getting there exponentially. So let's go ahead and try number 2. Again, I'm going to do a t-chart. You could just put y, we'll put 3 to the x. And now this time, instead of plugging in so many, let's just do -2, -1, 0, 1, and 2. So again, remember, any number raised to a negative exponent doesn't make the number negative. It makes it become a fraction. So this becomes 1/9. Over here, 3 to the -1 becomes 1/3. Anything to the 0 power equals 1. Then 3 to the first is 3. And 3 to the second is 9. Now I'll go ahead and graph these. And again, you're going to see that it's going to take on the same shape. It's just going to go up a little bit faster. So instead of going at when x = 1, instead of going to 4 or to 2, now it's going to 3. Sorry. So let's go ahead and graph these. -2 is at 1/9. And again, just put it just above the x-axis. Then the 1/3. Then the 0, 1. The 1, 3. And then the 2, 9. So again, connect the points. Take on this same curved shape. And again, have it come and skim along this horizontal asymptote. So when you're graphing these, I want to see you graph the asymptote and then graph at least 2 points. So I plugged in 5. You can get away with plugging in, say, 0 and 1. Let's try one more where the base is a number greater than 1. and then we'll do a fraction. Pretty good on number 2. Let's try number 3. Again, I'm going to do a chart. Again, I'm going to plug in even fewer numbers. You can plug in as many as you want. I want to see a minimum of 2. I'm actually going to plug in -1, 0, 1. So here, 10 to the -1 power becomes 1/10. 10 to the 0 power becomes 1. And 10 to the first power becomes 10. I can graph these 3 order pairs as well as my asymptote. So -1 and the 1/10, 0 and 1, and then 1 all the way up here at the tippy top for the +10. So again, you can see it's going up super fast and then skimming along the asymptote. So it still has the y equals 0 asymptote, and then we've graphed those points. Number 4, we're going to do one that has a base that is a fraction. So notice all 3 of the first examples we did, they all took on the same shape. Just some went faster than the others depending on the size of the base. So let's try number 4. I'm going to do a chart. Now because we're changing the base, I'm going to do a few more numbers just to get you guys to practice. So 1/2 to the x power. Let's plug in -2, -1, 0, 1, and 2. So 1/2 to the -2 power. Remember, when you have a fraction raised to a negative exponent, think reciprocal. You flip it upside down, make the exponent positive. This becomes 2 squared, which is 4. 1/2 to the -1, flip it, and this equals 2. Any number raised to the 0 power equals 1. 1/2 to the first power equals 1/2. And 1/2 to the second power equals 1/4. Now you're going to notice that your graph is going to flip. So for the fractions, it's going to go up to the left, but down to the right. Let's graph the order pairs. So -2, +4, -1, +2, 0 and 1, 1.5, and then 2 and the 1/4. So now this time it rises up to the left, but it's going down to the right. I still have the same horizontal asymptote of y equals 0. Let's try one more fraction. And then I'm going to introduce you to the letter E, which is going to be like pi. All right, everybody good here? All right, let's try number 5. Still a fraction. Let's only plug in 3 numbers. Let's just plug in -1, 0, and 1, since we've already seen what happens when we raise a fraction to a negative exponent. So let me plug in -1, 0, and +1. 1/4 to the -1 power. think reciprocal, so this equals 4. Anything raised to the 0 power equals 1. And then 1/4 to the first power is 1/4. So now I can graph these three ordered pairs. So again, -1, +4, 0 and 1, and then 1 and then the 1/4. Still have the horizontal asymptote, and then connect your points. Again, they all follow the same basic shape, skimming along that asymptote. The next example has the letter E. The letter E is not a variable, it's a number. Just like in geometry, you guys learned about the pi symbol, and remember pi was approximately 3.14. Just like pi, E is a number, and it's approximately 2.71. So if you have your calculator, and I'll show you my calculator on my iPad here, they tell you to truncate. And again, when you truncate, whatever's on your calculator beyond the number of decimal places they tell you, you just don't write them down. So we don't round, we're going to truncate. So in this chapter, we'll probably practice the truncating technique. It's a lot easier than rounding. So we're going to memorize that the value of E is 2.71. So if I were to do my little T-chart here, and I'm doing E to the X, I could just plug in -1, 0, and 1. So what I'm doing here is E to the -1, which is really saying 2.71 to the -1. So then you just move it underneath the 1. And if you think that 2.71 is about 3, so it's like 1/3, this is equivalent when you divide it to about 0.37, rounded. Then anything to the 0 power equals 1. So again, if you want to think of it as 2.71 to the 0, it equals 1. And then E to the first is really 2.71 to the first, which is 2.71. So I can go ahead and graph these points. So 0 and 1, this is the one that is going to occur in most of your graphs, except for maybe if it's been shifted or reflected. And then I can graph 1 and put it almost to 3, and then over here. So again, it's skimming along the asymptote, and then you graph those other points that you found. Pretty good? Let's keep going. All right, so for number 7, notice here we have our base raised to a negative exponent. Now, what you're going to end up seeing is once we're done, this graph is going to be the same. It's going to look the same as the f of x raised to the 1/2, or the 1/2 raised to the x power. These are going to end up being the same graphs. Now, coming up in another slide after this, this negative that's in here with the exponent, this is indicating that this graph is going to be a reflection across the y-axis. Now, let's say you forget, oh, that negative sign, what does it mean? You can always do your T-chart, get your ordered pairs, and you're going to see the reflection. So let's do the T-chart. Let's just plug in -1, 0, and 1. So if I plug in 2, put a 2 here, and then negative negative 1, this becomes 2 to the first, which is 2. And then here, even if I put a 0 here, there's no such thing as a negative 0, so anything to the 0 power is still 1. And then 2, and then the negative was part of the equation, and then I plug in the 1, 2 to a negative exponent makes it a fraction. So we can graph this, negative 1, positive 2, 0 and 1, and then the 1 and then the half. So it's skimming along that asymptote. And again, it looks like the fraction raised to the power. They're the same graph. The next one, when the negative sign is in front of the base, so when the negative here is in front of the base, so a negative in front of the base, this is going to be a reflection across the x-axis. So again, let's give ourselves a little T-chart just to demonstrate this. Negative 1, 0, and 1. Negative 3 to the negative 1 power. Now here's where you have to be careful. There are no parentheses surrounding this base. So this negative 1 power is only on the 3. And then the negative sign is going to go in front. So this is actually going to simplify to negative 1/3. Over here, it's got the negative sign, and then it has 3 to the 0. Again, you're going to evaluate 3 to the 0, which gives you 1, but then the negative sign falls in front. Over here, negative 3 to the first. Again, evaluate 3 to the first, you get 3, and then the negative sign goes in front. So now we can graph these ordered pairs. I still have the horizontal asymptote. And now let's graph. And you can see the reflection. Negative 1, negative 1/3. Negative 0, negative 1, and then 1, negative 3. So it's skimming here and then down. So it's been reflected across the x-axis. The next slide has all of the transformations in words. Just look here. So again, just like before, we're going to translate our functions or our graphs up and down, left and right. We'll reflect them, and we'll also make them go up faster and slower, where we'll be stretching and shrinking. So when there is a number added or subtracted to the base, this is going to be our vertical translation. This is going to go up and down. So when you're adding a number, it's up. And when you're subtracting a number to the base, you're shifting your graph down. In addition to shifting the graph, you're also going to shift your asymptote. For the horizontal translation, this is the left and the right movement. And just like before, it's backwards of what you think. So here, when you add a number to the exponent, it's like shifting left. When you subtract a number, it's shifting right. So think about the other graphs where we had parentheses. So that was when the shift was in the parentheses, it was backwards, it was left and right. And then when it was outside the parentheses, that was when it was up and down. When you shift your graph left and right, we're not moving the asymptote. It's going to stay at y equals 0. Now, in the previous two examples that we just did, we already showed the reflections. So in examples 7 and 8, this is when we applied the reflection. So when the negative sign is in front of the base, it's reflection across x. When the negative sign is up in the exponent, then it's a reflection across the y-axis. Then if there's a number in front of the base, that would be your vertical stretch or shrink. So if it's a number greater than 1, you're stretching your graph. If it's less than 1, if it's a fraction, you'll be shrinking the graph. And then the same thing for the vertical. It's backwards, so it shrinks when it's greater than 1, and it stretches when it's the fraction. And that'll be a number in front of the exponent. So now let's try some more examples of transformations. Pretty good on this. So here we have our first transformation example with a shift that is going to be up or down. So notice it is being subtracted from the base. So this is a vertical transformation. This is going to be down 2 units. So when it's the shift up and down, it's the number that you would think of it. So you're thinking a -2, it means it's moving it down 2 units. So let's go ahead. Now, instead of doing a whole t-chart for this whole function, I am going to graph just the x to 3 to the x power. And then I'm going to shift my points 2 units down. So easiest way to do it is just do the t-chart, just plugging in a 0 and a 1. So 3 to the 0 is 1. 3 to the first is 3. So I'm going to graph these order pairs, and then I'm going to shift these 2 order pairs 2 units down. So I'm going to graph 0, 1 and 1, 3. I'm going to go ahead and graph it. You also have your asymptote in here. Don't forget to graph that as well. And then make it skim along. Now I'm going to shift these 2 points and my asymptote 2 units down. So first let me shift the asymptote. I'm going to go down 2 spaces. So now my horizontal asymptote is now located at y equals -2. And then I'm going to take both of the order pairs, the 0, 1, move it down 2, and then move this one down 2. And again, it's still going to take on the same shape, but now it's skimming along the blue asymptote. It's a lot easier just to do the shifts versus doing a table and plugging it into the original function. You could still get numbers by plugging it into the original, but it's a lot easier just to apply the shifts. So again, when it's added or subtracted to the base, it's a shift vertically up or down. If it's subtracting a number, it's moving it down. The next example, what's going on is in the exponent. So this is the horizontal shift. And again, we're thinking backwards. So this is going to be a shift of 2 units to the right. Backwards of what you would think. So again, I'm going to graph just the y equals 3x first, and then I'm going to move all of my points 2 units to the right. When you're shifting left and right, your asymptote is not going to move. So I still have my horizontal asymptote here, at the x-axis. Let me redraw it here. And now let me graph the ordered pairs for this. 0, 1, and then plugging in a 1, I get a 3. And the original graph looks like this. But now I'm going to take those 2 points and shift them 2 units to the right. Asymptote stays the same place, and it skims along it. So same asymptote, y equals 0. So we're not moving the asymptote when it shifts left and right, only up and down. Going to try another one, same transformation. It's going to be left and right at a different base this time. So again, notice what's being done is in the exponent. So again, 2 units backwards of what you would think. So 2 units to the right. So let me go ahead and I'm going to graph now the y equals 4 to the x. So plugging in 0 gives me 1. Plugging in a 1, 4 to the first is just a 4. So let me graph those 2 points. Put on my asymptote, 0, 1, and 1, 4. And the original one looks like this. But now I'm going to take both of those points and move them 2 units to the right. Draw in and connect. And again, it's skimming along the asymptote. So the asymptote is still staying at y equals 0 when the shift is left and right. The next example has a shift up 3 units, so we will be moving the asymptote. So I'm going to graph f of x, or y equals 4 to the x first. Then I'm going to shift my entire graph, including the asymptote, 3 units up. So let's go ahead and again, same order pairs, 0, 1, 1, 4. Skims along the asymptote. And now let's move the points as well as the asymptote 3 units up. So 1, 2, 3. Here is the new horizontal asymptote at y equals 3. And I'm going to shift each of the points. And then again, it'll follow the same pattern. By putting that asymptote in there, it definitely helps you guide your graph. Remember, your graph will never cross that asymptote. We have 2 examples, and then we're done. Pretty good? This one is got a reflection, and it also has a shift. So this is going to be down 3. But this one is going to be reflected across y. So it's going to go, instead of swinging up to the right, it'll go up to the left. So let's first graph we'll graph this one. And then we'll just shift the points 3 units. So if I plug in a -1, I get 4 to the -1, which becomes 4 to the +1, which is 4. When I plug in 0, anything to the 0 power is 1. And when I plug in a 1, it becomes 1/4. So let's graph these, and then we're going to shift all of these 3 units down. So I'm going to graph 0, 1, -1, 4, and then this one. So here's this graph along with my asymptote. And now let me shift all 3 of these, including the asymptote, 3 units down. And then take each of these, 1, 2, 3, 1, 2, 3, and then here. And then it's going to follow the same pattern and skim. Yes?
Devon's laptop died and she's in the waiting room.
Okay, thank you. All right, one last example. See if we can get to it before the bell. We're shifting the E graph. So I'm going to first graph f of x equals e to the x, but then I'm going to shift up 2 and to the right 1. So again, you could graph the 0, 1 and the 1, e, which is 2.71. So let me graph those. So there's the basic graph with the horizontal asymptote. Let me shift my asymptote up 2 units. I'm going to go up 2, 1, 2, and to the right 1, up 2, and to the right 1. So here's your new graph. Shifted up 2 and to the right 1. So here, don't forget to shift the asymptote. Whenever you have a vertical shift. So we shifted everything up 2 units and then also to the right 1.